Accuracy and precision. Most numbers in technical and scientific work are approximate numbers having been determined by some measurement. Certain numbers are exact numbers having been determined by a definition or accounting process. When you have a significant digit, approximate numbers include some zeros to properly locate the decimal point. Except for those that are zeros, all other digits are significant digits. So 34.7, that's 1, 2, 3, three significant digits. 0.038, because the zeros are used to locate the decimal, it only has two significant digits. 706.1, this has four significant digits. The zero is not used for the decimal point, it's actually part of the number. 5.90, again, this is three significant digits because the zero is holding a place. 1400, this is only two significant digits because the zeros, these are placeholders, but they're placeholders because there's no decimal point. So you don't count these. So any zeros to the left of a non-existent decimal point are not counted. And the more examples, 0.0005, that's only one. These are all leading zeros. 96,000, this is only two. These are trailing zeros. 0.0709, this is three. These zeros don't count. 1.070, everything counts here, so that's four. And these will all count because the decimal point is making this significant. If I had a decimal point here with another zero, those would count. So this is 5. In calculations with approximate numbers, the number of significant digits and position of the decimal point are important. Accuracy refers to the number of significant digits. Precision refers to the decimal position of the least significant digit. So accuracy is for significant digits, precision is pretty much decimal position. And when you're rounding off, discard all the digits to the right of the last significant digit, replace it with zeros. If the first digit discarded is a 5 or more, increase the last significant digit by 1. If the first digit is discarded is less than 5, do not change the last significant digit. So 70,360, if I rounded to round this off to three significant digits, 1, 2, 3, there's a 6 here, so I have to round that up to 4, so it'd be 70,400. 70,430 rounded to three significant digits. Again, this 3 is less than 5, so it's going to be 70,400. 187.35 rounded to four significant digits, so I'm rounding here, so this has to go up to a 4 because that's a 5. 187.349 rounded to four significant digits. I'd still look here. I don't do a double rounding. It's just one digit over. That's less than 5, so that still stays a 3, so 187.3. When approximate numbers are added or subtracted, the result is expressed with the precision of the least precise number. When approximate numbers are multiplied or divided, the result is expressed with the accuracy of the least accurate number. When the root of an approximate number is found, the result is expressed with the accuracy of the number. When approximate and exact numbers are involved, the accuracy of the result is limited by the approximate numbers. For instance, if I want to add 73.2, 8.0627, 93.57, this I'm adding, so I'm looking at precision. This is one place after the decimal. 1, 2, 3. These are 4. This is 2. So this is the least precise. So I'm going to add up all my numbers, and then I'm going to get it to the precision. So 174, one place. This is a 3, so that stays at 8. So 174.8. I'm multiplying. Multiplying, I have to look at significant digits. 2.4832 has 1, 2, 3, 4, 5. 30.5 only has 3, so my answer will be in three significant digits. I multiply it out. Three significant digits is 1, 2, 3. It's right here. So this is a 3, so that stays a 7, so that's 75.7. Combining operations. Follow the order of operations, keep all digits for the intermediate steps, but keep track of all significant digits, then round off your final answer. So if I have 4.265 times 2.60 divided by parentheses 3.7 plus 5.14, this is multiplication, so I'm looking at significant digits. This has 4, this one has 3, so when I multiply it, This is only going to have 3, 11.1. This here is adding. This is a tenth. This is hundredths, so I'm using tenths. So I add it up and I get 8.8 when I keep that to tenths. Finally, I'm dividing. When you're dividing, you're looking at significant digits. There's only 2 significant digits on this one. This one has 3. So when I get my final answer, which is 1.25, I have to get down to 2 significant digits. So this is a 5 that goes up to a 3, so it's 1.3. 12.78 plus 1.0495 minus 1.633. I'm looking at the decimal positions. This has 2, this has 4, this has 3. I need to do 2 for my final answer. So I add them up on my calculator, subtract, and I get 12.1965, getting down to 2 places, because this is 9 and a 6 here. This is going to go up to 20. So I have to put the 20 to show the 2 places. 0.6572 times 3.94 minus 8.651. First I do the multiplication. This has 3 significant digits, this has 4. So when I multiply it, I want to go down to 3 significant digits, so that's 2.59 once I get down to 3 significant digits. And then I'm subtracting 8.658, but now I'm in subtraction. So even though this is 2.59, when I subtract, this is only 2 places where this is 3 places. My final answer has to be 2 places. So when I subtract it, I get a negative 6.06 down to 2 places. That's the answer, negative 6.06. The next one, 8.75 plus 1.2 times 3.84. First is multiplication. This has 2 significant digits. So after I'm multiplying, I'm going to get 2 significant digits. So when I multiply those, it's 4.608. So it's just 4.6. Again, this is 1 place because I'm now adding. This is 2 places. My final answer will only be 1 place. So 8.75 plus 4.6 is 13.35. 1 place means I change this to a 4 because that's a 5, so it's 13.4. Next one, 8.75 times 15.32 divided by 8.75 plus 15.32. So I'm multiplying, I'm looking at significant digits. This has 3, this has 4, so my answer will be in 3. I multiply it out, and I get 134.05. So it's just going to be 134 to get the 3 digits. This is adding, this is 2 places, this is 2 places, so answer will be 2 places. So 8.75 plus 15.32, that's 2 places. So I have division next, so I'm looking at significant digits. This is 3, this one is 4, so my final answer will be 3 because that's smaller. So 134 divided by 24.07, I get 5.567, and I need 3 digits, 3 significant digits. So it's going to be 5.5 right here, and that's a 7, so that goes up to a 7, so 5.57.